In Math 10C today, we're going to look at reviewing some factoring methods or introducing some new ones, and this is my factor tree. What we're going to do today is look at factoring. Now, factoring is a process of breaking down a polynomial into its simplest parts. What does that mean? Well, sometimes it means different things. The first thing it always means is that you have to remove the greatest common factor from the polynomial. So just as this tree comes out of the ground, this is how we start every factoring of a polynomial. The first thing you're going to do is you're going to remove the greatest common factor from that polynomial. As you move up the tree, we're going to see that we're going to either have 2 terms, 3 terms, or 4 terms to our polynomials. Now, depending upon the branch is going to be a different factoring method, all of which mean factoring. Today we're going to look at some simple trinomials, 3-termed expressions. So we're going to go to the top of the tree and we're going to look at factoring simple trinomials using what we call the sum product method. Now in the sum product method, we're going to learn how to factor something like x squared plus 7x plus 12. In the sum product method, we're going to learn a process that's going to break x squared plus 7x plus 12 into 2 binomials by taking the sum of the middle term and the product of the last term and breaking it apart. Now when we do this, the first term in each of those 2 binomial brackets is going to be the product of our first term in our trinomial. Notice it says x squared. Well, the only way to get x squared is if we multiply x times x. Next thing we do is we're going to look at finding 2 numbers that multiply together to give me 12, and those same 2 numbers are going to add up to give me positive 7. Well, the only things that multiply together to give me 12 are going to be 12 times 1, but that adds up to 13. So those don't work. 6 times 2, and that adds up to 8. That doesn't work. And the only one that runs is 4 times 3, and 4 and 3 add up to 7. That one works. So we can say that we can break this down into 2 binomials, x plus 4 times x plus 3. So in a little more depth, we're going to go into this. Let's begin inside. Here we go, factoring out a greatest common factor. Whenever you're asked to factor an expression, you must first look to see if there are any common factors that belong to all of the terms of the polynomial. You will divide each term by the greatest common factor and then rewrite the expression as the product of the greatest common factor and the quotient. Let's look at a couple of examples. In 6m plus 9n, I notice I can divide 3 into both of those terms, and so I can rewrite this as 3 times, and if I divide that, I will get 2m plus 3n. In the second one, 6y plus 1y, well, that simply adds together to be 7y, and I really don't have to factor that because it's already only one term. In C, 9ab minus 12ac. Well, I notice that I can divide a 3 into both of those, but I can also factor an a out of both of those terms. So this would be rewritten as 3a times, if I divided now, I would get 3b minus 4c, pardon me. In D, I have to look for something I can divide into all 3 terms, and that would be 5 and an x. Now if I went ahead and divided it, I can express my original polynomial as 5x times the quotient, which is 3x, minus 2y, minus 4z. And in the last one, again there's 3 terms. You look for something that the biggest thing you can divide into all 3. For 14, 21, and negative 35, I can divide 7 into all 3. I notice that I can divide an a squared into all three terms as well as a b squared into all three terms. That's the biggest thing I can get out of it. So I would write that as 7a squared b squared divided by each of those, and I'm going to get 2 plus 3a minus 5b. So that's how you factor out a greatest common factor. Let's look at factoring a trinomial in more depth now. To factor a trinomial like x squared plus 7x plus 12, you must find two numbers that multiply together to give you the last term, and those two numbers have to add together to give you the middle term. You'll then express this trinomial as the product of two binomials, x plus 4 times x plus 3. Notice that 4 times 3 equals 12, the last term, and 4 plus 3 equals 7, the middle term, or the middle coefficient. Always check to see if you can remove a greatest common factor first. So let's work through these. In the first example, we got x squared plus 7x plus 12. That tells me the only way to get x squared is if I go x times x. Now I need two numbers that multiply together to give me 12 and add up to 7. And those two numbers, as you already know, are only going to be 4 and 3. So one of these is plus 4, the other one is plus 3. In the second one, I'm going to factor this by finding x times x is x squared. Two numbers that multiply together to give me 4 and add up to 5 have to be 4 and 1. So this will be plus 4 and plus 1. In the third one, x squared plus 4x plus 3, well, this time, two numbers that multiply together to give me 3 and add up to 4, again, can only be 3 and 1. So we can say 3 times 1 is 3, and 3 plus 1 is 4. So it's going to be x plus 3 times x plus 1. In the next one, it's different. This time I got two numbers that are going to multiply together to give me negative 30 and add up to negative 1. That's different. Now they look more complicated, however there's many more clues for us to figure this out. Let's look at them. For two numbers that multiply together to give me negative 30 and add up to negative 1, here's what we can tell. Since two numbers multiply together to give me a negative 30, that means one has to be positive, one has to be negative. It also means that they're going to be one number apart when they add up to negative 1. It also tells me that the negative has to be one bigger than the positive number because they're going to add up to negative 1. So let's see now. Is that enough clues? Two numbers that multiply together to give me negative 30. They're going to be one number apart, and the negative is going to be one bigger than the positive. Have you got it yet? How about negative 6 and positive 5? Negative 6 times positive 5 is negative 30. Negative 6 plus positive 5 gives me negative 1. So this trinomial factor into x minus 6 times x plus 5. In the next one, I start out with a 4x squared minus 32x plus 48. 4x squared. That's big. Let's see if I can factor 4 or something else even more out of it. So let's look and see if I can factor out a GCF first. And I can. I can divide all of these terms by 4. So I can express this as 4 times x squared minus 8x plus 12. Now all I need to do is find two numbers that multiply together to give me positive 12 and yet add up to negative 8. So I'm going to break this remaining part into two binomials. Notice that it's all still times the 4 in the first place that we factored out. And this has got to be two numbers that multiply together to give me positive 12 and add up to negative 8, minus 6, and minus 2. In the last one, I have 3x cubed plus 15x squared minus 18x. When I look at this, I see that I can take out a greatest common factor, and the biggest thing I can divide out of all three terms would be 3x. So that would be 3x times an x squared plus 5x minus 6. So now I'm going to rewrite this as 3x times x and x. And now I need to find two numbers that multiply together to give me a negative 6. And yet those same two numbers are only going to add up to positive 5. Now this looks kind of tricky. And the first thing we're going to think about maybe doing is 2 and 3. But you got to remember that these two numbers are going to multiply together to give me a negative 6. And yet they're going to add up to be a 5. So they got to be 5 numbers apart. And the only way that this is going to happen is if one is negative 1 and one is positive 6. So we'll write the answer as 3x times x plus 6 times x minus 1. Notice that because it's multiplication, you could have also written this as 3x times x minus 1 times x plus 6. That's also going to be the same thing. Your assignment is going to be to do page 166, numbers 11 to 21.